remember in the ganglions and the retinal ganglions how they're separated into the P-type and M-type, and this is because the P-type of the retinal ganglion neurons, they only project towards the P-type, the parvocellular, in the LGN, and same with the M-type, they project only on the magnocellular of the LGN. Okay, this is important information which I should know. Why am I doing this like a day before the actual test is? So I should have done this like weeks ago. In addition to the neurons in the 6 principal layer, it was also there to cover the numerous tiny neurons that lie just ventral to each layer. Lie ventral to each layer. So if you think of the layers of it's like this, so ventral to each layer. So that's what we call the coniocellular LGN layer. So the coniocellular LGN layers, they lie ventral to each layer of the LGN. So like there's layer after layer. So if you think about it, there's 12 layers then. It's like numerous tiny neurons, okay? Receive input from the non-M and non-P type of the... Okay, so there are non-M and non-P types, and those, they innervate the coniocellular ones, also project into visual cortex. For most part, each coniocellular layer gets input from the same eye, as the overlaying PM or P layer. Okay. With K1, there's called K1 to K6, and they're innervated the non-M or non-P type. Okay. I'm so stressed, bro. Receptive field. We saw the receptive field of the retinal ganglion cell can be mapped out according by recording from the neurons positive light shown to the retina. Similarly, by inserting a microelectrode into the LGN, it is possible to study action potential discharge of the geniculate neuron in response to visual stimuli. The surprising conclusion of such studies is that the visual receptive fields of LGN neurons are almost identical to those ganglion cells that feed them. I see. The visual receptive field is almost the same. For example, magnocellular LGN neurons have relatively large center surround receptive field which respond to stimulation of their receptive fields and a transient burst of action potential. So what we found was that the magnocellular is like transient burst of action potential, while the parvocellular are more not transient. How do I say that? Sustained action potential. We have an exhibit color opponency here, where the cones are for dark and yeah. So if you look at this, right? I see. Yeah, I see what it means. Yeah. Okay. So non-retinal inputs to the LGN will make similar to LGN ganglion cell receptive field. Surprisingly, is that retina is not the only main source of this genetic information. In addition to the retina, LGN receiving from other parts of the thalamus and the brain, the major input is 80% of the excitatory synapse comes from the primary visual cortex. Oh damn. And I am telling you, I'm not growing the best that I ever known. So the major input considering 80%. So remember that the LGN not only receives input from the retinal ganglion, but it also receives input from the higher order neurons, which is the primary visual cortex. So this is called what we call a top-down modulation. So LGN also receives input from the primary visual cortex. The primary visual cortex, and this primary visual cortex is an example of the top-down modulation. Okay. The LGN also receives synaptic inputs from neurons in brainstem, whose activity is alertness and electron. I'm so stressed. Oh my god. My exam is tomorrow. I haven't finished studying. The LGN has a single major synaptic target, and another with this striate cortex and is the primary visual cortex. Okay. Visual connection and primary visual cortex and primary visual are the V1 or striate cortex. Should we look at the nebulous red cortex trace connection by LGN make? Later we'll explore the retinotopy. Just starting in the retina, extending to the LGN and the V1, which is a primary visual cortex. Striate cortex, or V1, as general organism feature of the central. It's an organism whereby neighboring cells in retina feed information to neighboring places in their target structures. In this case, LGN is right. In this way, the two-dimensional retina is mapped onto the two-dimensional. There are three important parts of the retina. First, the mapping of the visual field. The mapping of the visual field onto retina structures often serve because visual space is not sampled uniformly. I see. One of the many more cells in the target structure to develop receptive field. The point of light on the retina actually activates a large population of cortical neurons. The point of light on the retina actually activates a large cortical neurons, separate neurons, and thus, when retina is stimulated by a point of light, the activity in the striate complex is a broad distribution with a peak corresponding to retinotopy. Neighboring locations on the retina. Project to neighboring locations in the LGN. The surgery is represented with the LGN projection to V1. The lower portion of the LGN represent the top half of the visual space, and the upper portion of the V1 the top half of the visual space, and the upper portion the top bottom half of the visual space. More tissue devoted to analysis. Girl. Lamination of the striate cortex. The cortex in general have neuronal cell bodies arranged to half dozen layers. These layers can be seen in nasal stain. At least 9 distinct layers of neurons. 3 sublayers and 2 layers. Why would you, bruh? Ugh. This is crazy. Why would you do that? Combine 3 sublayers into layer 4, sublayer 4A, 4B, 4C. The 2 tiers, 4C alpha, 4C beta. Beta. And chips have identified a striate cortex bit. The cells of different layers, many different neuron shapes have been striate cortex, 2 principal types. Spiny stellate cells, spinal radiated from the cell body. They are seen primarily in 2 layers outside of pyramidal cells. They are seen primarily in 2 tiers of layer 4C. Outside layer 4C are many pyramidal cells. So basically there's pyramidal cells and the spiny stellate cells. Spine covered dendrites. What does that mean? These neurons are also covered with spines and are characterized by a single thick epidendrite. Okay, that branches as it ascends towards the pia mater and by multiple basal dendrites that extend horizontally. Multiple basal, okay. As in a single neurite descending from soma. Notice how pyramidal cell in one layer may have dendrites extending to other. One layer may have dendrites extending to the other layers removed, so only pyramidal cells send axons out of the striate cortex to form connection with other parts of the brain. So remember that the spiny stellate cells, they don't form axons that go out of the striate cortex, and only pyramidal cells, they form these projections of the axons that go out of the striate cortex and into other parts of the brain. The axons of the stellate cells are indistinguishable from dendrites in figure 10.13. Oh, I see. So the stellate cells are in the 4C, while the pyramidal cells, they're outside of the 4C. So as you can see in the stellate cells, you can barely notice the difference between the dendrites and the axons. So the neurites looks the same, and so the axons projection, they don't go outside of the striate cortex. Only pyramidal cells do that, as you can see in here, with pyramidal cells with axons extending almost outside of the striate cortex and into other parts of the brain. Okay, general male, an exception is for spiny stellate of layer 4 beta project to area 5. This illumination of the striate cortex is similar to the layers you saw in LGN. Yep, it is. 1, 3, 5. No, 2, 3, 5, and 1 for 6. Of the LGN is divided into streams of information with a mapping cell and power cellular layers serving your right and left eyes. The streams is aerated layer. Magnocellular LGN neurons project primarily to layer 4C alpha. So basically LGN, they project mainly to layer 4, and especially magnocellular for 4C. C, and then represent 4C alpha will parvocellular 4C beta. Wait, 4C alpha is on top of 4C beta? Yep, it is. Because important agents are intermediaries when the internal will be written in demand one from the magnocellular LGN. I see. Okay, involve the conio cellular LGN equal to layer 1 and 3. Motion of their cortical layers from layer 4C, motion. I'm so tired. Ocular dominance column. Axons project from layer 4C to more superficial layer. Most layer 3 neurons receive binocular input from both left and right eyes, while there are layer 3 neurons who are responded by the right eye, left eye, or roughly equal responses. I see, because of the radial connectivity of the striate cortex, neurons in layers above and below layer 4 are dominated by the same eye. Because of the radial connectivity in the striate cortex, neurons in layers above and below layer 4 are dominated by the same eye. Ocular dominance column between vertical dotted lines contain neurons with input dominated by one eye, and the column are alternate between left and right eye dominance. So it's an alternating left eye, right eye dominance. All layer 4C neurons receive input from only one eye. Most neurons in layer 3, 2, 3 receive some amount of input from each eye. For example, a neuron above the left eye patch on neurons in layer 4C receive input from so the input is dominated by the left eye.
세게 버틸 수 있는 거. 그래서 하는 거는 이제 또 반대로 계속 버틸 수 있는 거. 이걸 통해서 이걸 하고.
Layer 6, the one that goes with the LGN.
주요 시대를 불러보지.
I'm tired, oh my god.
특히 나가야 될지 몰라. 그게 제일 중요한 것 같아. 지금 보면 시간 따라 아니면 아까 그런 문제처럼 직경에 따라 또안 보면 여기서 제일 세다 이거 제일 세다 라고 말해줬어. 그래서 아까 이걸 쓰면 그냥 이거든. 나는 이거 20도를 미쳤나도 생각했는데 그냥 나는 의미 없어. 그냥 그게 결과가 온 것만 하면 너무 딱히 있으면 이거 그러면 스태틱 로드라는 걸 말한 거는 그냥 디스토션에서 이걸 쓰란 말이야. 왜냐면은 패진하고 있으니까 사실 디스토션을 쓰는 스태틱이 아니잖아. 근데 그렇죠. 횡령을 했는데 횡령 없이 디스토션을 그렇죠. 그거 가지고는 그렇게 플럭추에이팅 해가지고 학생 이거 횡령을 할 수 있는 거 그래서 그냥 정신을 같이 써라. 아니 숙제랑 그때 지금 가가지고 태클을 주면 해야 되나? 태클을 주고 막 이거 줘. 여기 뭐 이 직경기, 직경기 직경기만 하면 돼요. F 값이 어쩌면은 우리가 아까 풀었던 방법대로 P는 사실 그때 P는 0일 때 이거 했었잖아. 이거 아까 그 풀이에서 P는 0일 때만 기능해서 이거를 이렇게 하셔서 P는 0이겠지? 이게 있었어. 이거 이게 있어가지고 이거 썼잖아. 이거 없으니까 그래가지고 어떻게 할 수 있는데 이거 쓰고 이거 쓰고 하면 나눠주고 시간이 안 바뀌면 그 힘이 시간에 따라 안 바뀌면 그 말대로 그 평균 액츄얼 로드가 될 수밖에 없어. 엔딩은 최대 그처럼 시간 내면 정석대로 그런 거지. 그게 있어야지. 축의 예전에 딱 스테이 이게 이건 저도 처음 봤어요. 뭔가 이 문제나 수점이 좀 맞잖아. 내 생각에 그냥 중간고사 작년에 중간고사를 숙제를 잘 내시는 것 같아. 뭔가 내 생각에 중간고사 만약 시험은 엄청 다른
dorsal ventral. Okay. So dorsal is for the movement, while ventral is for the recognition of objects. Subcenter surround structure. To contrast the movement flight and strain orientations.
축의 회전에 따라 스테이지 이 말이 이게 그럼 그 스테이트 볼때는 이렇게 하기로 약속했으니까 딱히 이건 이유가 없습니다. 그 강연에도 그 스테이트 볼때는 그렇게 한데 궁금해서 내가 이유를 알 것 같아서
Okay. Now I'm done.
그거에 대한 이론적인 거
I cannot sleep though.
얘는 그걸 똑같이
I need to like buy a monster. I'm gonna buy monster. I'm friends with the monster. Is it lagging? I think it might be lagging. I'm friends with the monster under my bed. You think I'm crazy, you think I'm crazy. And I better do.
1층입니다.
Now I'm gonna buy the monster.
봉투 필요하세요? IC 카드 결제 시 카드를 단말기에 끝까지 밀어넣어 주세요. 카드 거래가 끝났습니다. 카드를 가져가 주세요. 거래가 완료되었습니다. 감사합니다. 1층. 문이 닫힙니다. 개인.
I'm scared that I will have so wow. Wow, I made a mess. Well, okay. But I do have that water. First of all, clean this mess. Oh god. That's for sure. Do I want to read the rest of that thing, or I feel like I can understand most of these by myself? Hey, where did it go? So I need to like get far. Map of the initial field onto a target structure. Okay, strike cortex. Point of flight can activate his engine. Not literal map. I don't know how she's going to like make the questions from these. Like, what is going on? Anyway, okay, let me just start from the very beginning. So basically, in this part is essential vision. So this part we're gonna learn how the signal transduction from the retinal ganglion is being processed in the brain, in the central nervous system. And so remember that the way it works is that the retinal ganglion, so from the photoreceptor, light hits, and then the rhodopsin the rhodopsin changes from the 11 cis into all trans conformation, so it's isomerization, and from there it binds to the G protein, in this case is transducin, and then which mediates the exchange of the GDP into GTP. From there, the activated transducin, the GTP bound transducin, can now activate phosphodiesterase, and the activation of phosphodiesterase basically hydrolyzes the cyclic GMP into GMP, which means that the cyclic GMP gated sodium channel will be inactivated, which means no more influx of the sodium channel, which means the cell will be hyperpolarized, which means no more of the no more of the release of the neurotransmitter. But then on the bipolar cell, this leads to the depolarization of the bipolar cell, and then from the depolarization of the bipolar cell leads to the activation of the relay of the transduction signal relaying up to the ganglion cell, and from the ganglion cell then it travels to the LGN, right? But the thing that we need to know is that the retinal ganglion cell itself is divided into what we call a nasal what was the name? The nasal periphery, the nasal retinal cell, and also the temporal retinal part. So there's a nasal, so there's the peripheral part of the retinal ganglion, right? So the nasal peripheral part, and then there's a temporal peripheral part. So for the left nasal retinal retinal ganglion plus the right temporal ganglion, that makes the left visual hemifield, while the right nasal ganglion, right nasal peripheral ganglion, retinal ganglion plus the left temporal ganglion makes the right visual hemifield. And so what happened is that the left nasal one basically kind of like decuss, or basically cross over at the chiasm into the right part of the brain. And so it's kind of like a contralateral, like a hemi-decussation. And then it's the same thing with the right nasal retinal ganglion. It decusses at the chiasm towards the left part. Okay, and so that's how it works. And so if you cut the optic, so there's the optic nerve, the optic chiasm, and then the optic, what's the name? Where is it? Optic nerve, optic chiasm, and optic tract. If you cut the optic tract, then basically you will not be able to see the. So for example, if you cut the left optic tract is here. So if you think about that, you're cutting the left optic tract, then you basically cannot see the right visual hemifield. Yeah, because the left optic tract, that part is composed of the right nasal retinal ganglion and also the left temporal ganglion, and those two makes the right visual hemifield. And so if you cut that part, you're basically gonna lose the right visual hemifield. So remember, cutting at the optic tract on the left side will impact the hemifield on the right side. Cutting at the optic tract on the right side will impact the hemifield on the left side. So this is contralateral. This is what we call a contralateral kind of thing. Right, and so, but anyway, from the retinal ganglion, it goes to the what we call a lateral geniculate nucleus. From lateral geniculate nucleus, then it goes to this striated cortex, or striate cortex, or what we call a primary visual cortex. And then from the primary visual cortex, then the axis branches out to other parts of the brain that basically converges and make the visual image, right? And we also learned that there's superior colliculus. Superior colliculus is basically important in noticing familiar objects because it kind of like modulates the movement of the eye. I believe the motor movement or something like that. And then protectum is the one that controls the pupil size. But also the ones that control the lens is all what we call a ciliary muscle, and the ciliary muscle is controlled by the oculomotor neuron. Yeah, right. So I already know about that part, which is important. And then the hypothalamus. Remember that the LGN itself is in the dorsal thalamus, but the hypothalamus is different because hypothalamus is in the biological rhythm, including sleep and wakefulness. So hypothalamus in the circadian rhythm or biological rhythm. Protectum is for the size of the pupil, and the superior colliculus, there's double L. Superior colliculus is the one for the noticing familiar objects, and also for the movement, I think. Orient the eye, orientation. Move fovea to objects of interest. Orients the eye in response to new stimuli, which means it moves the fovea to objects of interest. So remember superior colliculus, it orients the eye, or specifically orients the fovea to object of interest, depending on the new stimuli. Hypothalamus is involved in the biological rhythm or circadian rhythm, and the protectum. I just need to write this. I feel. Let's just write this. So protectum it modulate or control the pupil size. And then hypothalamus is one that in biological rhythm, and then the superior colliculus is the one that modulates or orient the eye in response to new stimulus, which is to move the fovea to object of interest, which is important in object recognition. So if you look at the LGN, what you will see is that there are 6 total layers of the LGN, the lateral geniculate nucleus, and from the first and second layer from the ventral side. So if you look at it from the ventral side, first, second, third, fourth, fifth, sixth, the first 2 most ventral part, they're really big. The neurons are big, and so those parts we call magnocellular, and then the rest 4 we call it parvocellular. Magnocellular, the difference is that for magnocellular, the action potential is really transient, and the parvocellular, the action potential is quite sustained. Another thing is that these parts of the LGN, the magnocellular and parvocellular, they're basically they receive the input from the M type for magnocellular, and from the P type of the parvocellular from the retinal ganglion cell. So those things we need to know. And then remember that for the there's 2 parts, right? In the brains there are two hemisphere, right? So there's the left side of the LGN and then the right side of the LGN. And so with regards to the LGN itself, for the layer 235, layer 235 is the one that receives, I believe is was it the contralateral? Wait, let me see. 235, no, ipsilateral. So ipsilateral, so if you think ipsilateral, right? Yeah, where I wrote this down. Not this one. Not this one. Not this one.
아 이번 주. 그러니까 근데 왜 그때야? 그러니까 왜 다음 주가 아니라 다음 주야? 다다음 주는 야간
아?
시기를
진행이 힘들어.
아니 근데 굳이 왜 이렇게 멀리 잡아? 아니 뭐 솔직히 바닥 해주는 사람이 나 날짜를 정하고 해줄게 이런 거 하면 안 되지. 아니 나도 확실하지 않은데 바쁠 시기지.
I swear to God, I wrote it. So right LGN, from ipsilateral, so from the right nasal, right inner ganglion.
손도 뭐 날짜까지 그냥 정하고 주객 정도 아니었나?
둘다 표면에 압축 잘 눌려줄 것 같아.
굳이긴 한데 해주면 좋긴 한데.
목을 딱딱딱 때려서 표면 딱딱하게 해서 압축을 딱 주고 표면 딱딱하게 이렇게 해서 압축을 주고. 표면은 열줘서 딱딱하게 해서.
Wait, I need to like read it.
나는 오히려 이게 안 나을 것 같은데. 알비트로는 줄 수 없잖아.
Right LGN receiving information to the left about the left. Right. So the right LGN receives information about the left visual field. The left visual field is viewed by both the nasal left retina and temporal right retina. LGN input from the two eyes kept separate in the right LGN and the right eye ipsilateral axons. The right eye, the ipsilateral axons. So that means it's the temporal one, not the nasal one. So in the right eye, the ipsilateral axons, which is the Oh no. Wait, what? In the right LGN, which receives input from the left visual hemifield, which means it's from the left nasal plus right temporal, right? Which means that the right eye ipsilateral axon synapse on layer 2, 3, 4, those are the right temporal, the right temporal axons, and the left eye. In the right LGN, the right eye ipsilateral axon synapse on. And the left eye contralateral axon synapse on the left eye, which is the contralateral, is the nasal one, which is the 1, 4, 6. Okay. Oh, I'm sick.
뭐가 됐든 뭐가 뭘 못하게 되는 자연스러운 거지.
Bladder-brain, yes.
누구나 가능한.
It is bladder-brain. The brain is not braining though, like. So remember, this is getting very confusing, but like basically, the left, let's say the left LGN, it receives the left LGN receives the right visual hemifield. Am I right? Right LGN receives the left visual hemifield, receives right visual hemifield, and the right visual hemifield is composed of the right nasal retina plus the left temporal retina. which means in the LGN, which is the left LGN, the ipsilateral one, which is the left temporal one, is going to be innervating 2, 3, 5, while the right nasal retinal one, which is the contralateral one, is 1, 4, 6. Am I right? Yeah. Yes. But yes. But then yes. Yes. Which means that whoever made the brain is so I hate this. Okay. Yep. I got it. Okay, and then the right. So if you think about it, the right LGN then. What happened to the right LGN? The right lateral geniculate nucleus. It receives the left visual hemifield. Left visual hemifield. Huh? Yeah, hemifield. I'm so stressed. Left visual hemifield, which means it receives the left nasal ganglion, retinal ganglion, plus the right temporal retinal ganglion, right? Which means that since this is the right, so the ipsilateral one would be the right temporal one, which is the 2 and 3 and 5, and the left nasal ganglion, which is the contralateral one, which will be 1, 4, and 6. Yes, and then remember that the first two from the ventral side, there's most ventral, is type of the magnocellular neurons, and then the rest of the 4 is the parvocellular neurons. And the thing that you need to know is that eventually to each layer of the LGN, we have this thing called the coniocellular. So the coniocellular, it receives input from the non-P type or non-M type of the retinal ganglion. Conio, is it conio? Yeah, conio. Yes, okay. And so receptive field of the LGN neurons almost identical to the ganglion fields, ganglion cells that feed them, right? And so magnocellular LGN neurons, large center around receptive field with transient response. Parvocellular, small centers surround receptive field with transient. Just remember that the receptive field of the LGN neurons are almost similar to the ganglion neurons, retinal ganglion neurons that feed them. So that means that the magnocellular receptive field is similar to the large center surround receptive field of the M-type neuron, and also the parvocellular is similar to the small center surround receptive field of the P-type. And remember that the parvocellular is more sustained of the action potential, and the magnocellular has more transient action potential, transient response. I just need to know that, right? And then the non-retinal inputs to the LGN, non-retinal inputs of the LGN is basically from the top down. Remember that the top down modulation, which means that from the primary cortex, primary visual cortex, it goes back down to the LGN to modulate it. So that's the non-retinal inputs towards the LGN. 80% of it comes from the stupid ass primary visual cortex. I believe it's from the layer 5 axons. Axons from the layer 6. So yeah, axons that from the layer 6, it goes back down towards the LGN to basically provide some modulation, right? So this is called with a top-down modulation, which may gate the bottom-up input from LGN back to cortex. Yep. So brainstem neurons provide modulatory influence on the neural activity. Okay, it's kind of like a feedback loop, basically. Yeah. Anatomy of the striate cortex. So there's the basically with the striate cortex itself, there's 9 layers. Then because of some guy wanted to be 6 layers, they have to like make a sub layer basically. So originally there's 9 layers. Anyway, so there's layer 1 to 6, but then in layer 4, there's layer 4A, 4B, 4C. Was there 4D? I forgot. No. It's gonna be 4 until C because the total is 9. I cannot do math. And for layer 4C, there's also sub layer of 4C, which is 4C alpha, 4C beta. And so if you think about it, it's just like layer 6, 5, 4, 3, 2, 1. With the 1, I think is the most superficial one. And then at the layer 4, there's 4C, B, A. And then at the layer 4C, there's layer 4C beta and 4C alpha. So it's like stacked like a pancake. So your brain is stacked like a pancake. Crazy. Oh my god. And then in terms of retinotopy, retinotopy is basically like a visual map onto the target structure. So so a map of the visual field onto the structure, but it's not really a real map. It's like a brain interpretation of the visual information that you get from the retina, right? And so from the retina to the LGN to the superior colliculus. Remember the superior colliculus? It basically the ones that kind of like move or move the fovea towards the target object. To kind of orient the eye towards a target object upon new stimulus, and the striate cortex, which is the primary visual cortex. And so the central visual field, the fovea, over represented in the map. So basically what happens is that it's just not a real map, it's just a perception, interpretation of the distribution pattern. So if you think about it, the map itself in the striate cortex, it looks like the reversed image. The image is upside down. So that's the thing. Okay, I get this. I just really need to remember, and there are 2 types of the axons in the striate cortex, or what we call the primary visual cortex. That is the spiny stellate cells and also the pyramidal cells. For the spiny stellate cells, basically the axon is very, very short. Which you cannot really distinguish the axon between the axon and the dendrites, and so they don't project outside of the striate striate cortex. But then the other ones, the pyramidal ones, they are found outside of the 4C. So mostly those stellate cells are in the 4C layer. But other than that, most of them have the pyramidal cells. And with regards to pyramidal cells, their axons are longer. The axon can project towards outside of the striate cortex towards other brain regions. Okay, so I need to know that. And the spiny stellate cells in the spine. I already know that. So I already know this. And then inhibitory neurons select spine all cortical layers for form local connections. Spines all cortical layers form local connections. Get input from fourth neuron. So what happens is that the fourth layer neurons gives input towards the second and third layer, and so from second and third layer go to the fifth and sixth layer, and then sixth layer go back to the LGN. Okay, input to the striate cortex. And the cellular LGN neurons project parameter to 4C alpha, paracellular 4C beta, coniocellular LGN makes synaptic parameter to layer 1 and 3. Okay, so just like the simplified version. Okay. Bro, I'm so tired of this thing. I'm so freaking tired, bro. So yeah, I just have to like do one more chapter, and after I do that one more chapter, I just need to like review everything, and after that I'm done basically. It's my fault because I didn't study this in advance, which is kind of stupid. Like, I did not study this in advance. Should have read the book from the start. Where's my phone? Oh, there's my phone. Wait a minute. Let me see. Oh, okay, remember. So there are 6 layers, right? And then remember that the layer 4, the fourth layer, it gives input to the second and third layer. From the second and third layer, it gives input back to the 5th and 6th layer. The 6th layer is the one that gives input back to the LGN, that modulate the input from LGN to the striate cortex. So what happened is that in the LGN cell, the magnocellular type of neuron, they basically give input to the 4C alpha layer. And then for the parvocellular, it gives input to 4C beta layer. For the coniocellular, it gives input to the where does it give input to coniocellular? It gives input to the first and third layer. Yep. A study with the transmography and blah blah blah. Okay, I don't need to know that shit. Okay, and then this thing called the binocular dominance, the ocular dominance. So ocular dominance is basically the striate layer is there's this thing called the ocular dominance column. So the column dominance is alternating from the left eye dominance, right eye dominance, stuff like that. And what you will find is that in the third layer you can have both dominance of the left and right eye. First binocular neurons are in striate cortex, third neurons are binocular. First binocular, but not layer 4. So layer 4 is predominantly, like only one of them is dominant. They need to mix up. The cortical areas for B cells. Second, third, and 4B layer 5th go back to the superior colliculus and pons. Layer 6 go back to the LGN. Okay. So for second, third, and 4B go to other cortical areas. For layer 2, 3, and 4B, it goes to other cortical areas. For layer 5, it goes to the superior colliculus and pons. Layer 6 go back to LGN.
수민이는 뭐 이렇지. 수민이 있으면 수민이가 문제가 한가.
Pons and superior colliculus.
옥주도
Okay.
여자가 많이 와버리는 오히려.
And remember that the third and second layer it receives input from the fourth layer, right? Cytochrome oxidase blocks or mitochondrial enzyme is also metabolism. Same pillars in the striate. They are centered on an ocular dominance column in layer 4. So basically, each blood vessel is an ocular dominance column, which means that in that specific column, the input is dominated by one eye. Monocular receptive field, layer 4C, similar to LGN cell. Layer 4C alpha insensitive to wavelength. Center circle color openancy. Binocular receptive field. Superficial. Receptive field.
집에서는 조금 장어탕도
I see what it means. The receptive field may be composed of 3 LG inputs.
27,000.
May be composed of 3 LG inputs.
같이 하는 것 같을까?
May be composed of 3 LG inputs from cells with aligned center surround. Oh, I see what it means. Complex or binocular, orientation selective, on and off response to bar of light. But unlike simple cells, no distinct on and off region.
거의 두 번 됐지. 첫날 3시간 자고 주제에서 아이스. 약 발라가지고. 주영 데리고 가자. 지수도 있으면 가지고. 딱 좋다. 그 내용에서 가자.
신양이 데려왔어.
쓰듯이 문제 없을 때 없나?
아 찜질방 뭐올 수도 있어.
놀러 가도 갈래? 진짜.
아니 우리끼리 가자. 아니 왜냐면 또 이 시험 부르고 또 누구 부르면 걔는 좀 부르지 마자 이런 소리 나오면 그러니까 그냥 남자들끼리.
에버랜드는
그 에버랜드 여자랑 가는 게 그림이 좋은데 이 찜질방 여자랑 가는 게 좋지 않아.
저랑
태훈이 뭐지 썸녀 3한테 쳐봤어. 썸녀 3한테 쳐봤어. 조용한 줄 알았는데 제일 많은 임소은 친구가 보니까 근데 임소은보다 더 많은 것 같아. 홀감 충분히니까 한승희 교수님 아니야? 학술제 교수님이었어. 학술제가 연구실인데 그전 대학 출신 그냥 학우들 송모아 선배들 부르는 건데 일차는 그 교수님이었어. 한승희 교수님 재밌어. 인생 경제가 알려줄지. 하버드 출신이잖아.
Just remember that the layers 2, 3, and 4B project to other cortical areas. Layer 5, it goes to the superior colliculus and to the pons, which superior colliculus is to orient the eye towards the object upon new stimulus, target object. And then layer 6 goes back to the LGN and cytochrome oxidase swap. So cytochrome oxidase enzyme important in metabolism in mitochondria, and it's used that blob is within the ocular dominance column. So ocular dominance column is usually located in the fourth layer, in which it is sensitive towards input from one eye, so alternatingly one eye. But then superficial to layer 4, it kind of like converge, where there's like binocular, not ocular, not monocular dominance, but like binocular, in which both input kind of like emerge, I guess, in a way. Yeah. So it's not binocular, it's not a monocular receptive field, binocular, yeah. So for the monocular, like ocular dominance or like monocular receptive fields is mainly on layer 4, especially for layer 4C alpha. 4C alpha is insensitive to wavelength, and 4C beta centers around color. So 4C alpha is sensitive to wavelength, which means it's metacellular, and 4C beta is sensitive to 4C beta is for color potency. Centers around color potency, and then binocular. Most dimensional layers supervision to 4C are binocular. You have 2 receptive fields, one for each eye. And orientation selectivity. So sometimes cells can be sensitive towards a certain orientation of the stimulus itself. Sometimes there's direction selectivity, in which the neurons fire action potential in direction-dependent manner of the incoming stimulus. And then a simple cell for self-field. So for simple cells, like it's usually binocular, it's not direction sensitive or orientation sensitive, is it? Elongation on off area flying with antagonistic surround. I see. Receptor may be composed of 3 LGN inputs. That is possible for a complex cell. It's binocular orientation selective or sensitive bar of light, but unlike simple cells, no distinct on and off region. Okay, so the difference between a complex cell and simple cell receptive field is that for simple cell receptive field, Orientation is direction selective, or no, orientation selective. Orientation selective, they're also binocular, which means both inputs, one of each eye, inputs from both eyes. Binocular, it's orientation selective, which means the orientation, it's only selective for a certain orientation of the stimulus. Orientation selective, and also there's a on and off center with antagonistic surround. But then for the complex cells, there's no distinct on and off region. Instead, you have like a bar,
후회가 없지 않나?
complex, like a bar of light. So on and off responds to a bar of light, but there's no specific region. There's no defined region for the on and off, and that's for the complex cell receptive field. For the blob receptive field, some blob fields, monocular, no direction selectivity, likely orientation selectivity, variety of color opponency and surround organization, special for analysis of color. So for the blob receptive fields, remember there are three types: the simple receptive field, simple cell receptive field, complex cell receptive field, and the blob receptive field. For blob receptive field, it's usually monocular, and it's no direction selectivity, maybe orientation selectivity, but some blob fields, and variety of color opponency and surround organization. So for blob receptive fields, for analysis of color, okay. So I need to remember that the blob receptive field, for example, it's specialized for analysis of color. It's also monocular. It's not direction selective. Maybe orientation selective though. And it's variety of opponency, like the orientation selective and the blob field. Right? And then there's simple cell receptive fields, in which it's orientation selective, is binocular. There's an on-off center with antagonistic surround. For the complex cell, is orientation selective, binocular, and it responds to on-off response to a bar of light, but no defined on and off region. Okay? And so parallel pathways, if you think of the parallel pathways, you can see there's the magnocellular blob parvo interblob pathways. Just remember magnocellular is always towards the 4C alpha, while the parvocellular is 4C beta, and the parvocellular, like that, p-type. And then interblob and cortical area, extrastriate cortical area. I see. So the blood point is from the corneal cell. Damn, what the? I hate neuroscience, bro. Thank God I'm not a medical student. Can you imagine if I'm a medical student? That would be crazy. So parallel pathways. There's the blob, the parvo, interblob, and there's the magnocellular pathway. Remember from the M side, ganglion, retinal ganglion, towards the towards the LGN. Magnocellular neuron in LGN. And then towards the 4C alpha, and then in the striate cortex, and then after that it goes to the extra striate cortex area, which means outside of the striate cortex. And then for the parvo interblob, one is basically from the P type of retinal ganglion, and then go to the parvocellular neurons in LGN. And from there, 4C beta in the striate cortex. From there to the interblob to the extrastriate cortex. For the last one, which is the blob is basically when you have a non-M or non-P type retinal ganglion, which then gives inputs to the corneal cellular in LGN, and then from the corneal cellular it goes to the blob, and then from the blob color is it color analysis of color, yeah, and extrastriate cortex. Blah 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 blah. So beyond striate cortex, wow, this thing is crazy, bro. 잡해. Oh my god, so 잡해. Wow, if I like write this whole ass mechanism, it would be like freaking pages. It's okay, so dorsal strings were analysis of visual and movement, visual motion and control of action, visual control of action, visual movement for ventral ones is basically recognition of objects, perception and recognition. So dorsal string, basically analysis of control of motion, control of action, right? No, not control of motion, analysis of moving object, visual motion, and control of visual control of action. Visual control of action, while the ventral stream is basically analysis of object recognition and also perception of the world. MT area. Do we need to know like F1, F2, F3, MT? What the fuck is F anyway? Like, I mean V1, V2, V3, MT, MST. What are those? What? So for dorsal stream, 1, 2, 3, and T, ST. T is parietal, the temporal lobe. MST is parietal lobe, and then MT is direction selective, respond to motion objects that rather than shape or parietal lobes for navigation. And the MST, directing eye movement, motion, perception. Okay. While the ventral system V1, 2, 3, 4, and IT. So V4 is for shape and color. IT, achromatopsia. See major alphabet V4. visual perception and memory. Colors and abstract shape. Wow. Amazing. So this. There are dorsal and ventral stream. Dorsal stream is basically for visual analysis of visual emotion and also visual control of action, while the ventral one is basically for object recognition, also perception of world, right? And so with regards to the dorsal one, there's V1, V2, V3, MT and MST. For MT is basically the one that responds that is important for recognizing or analyzing motion, visual motion rather than an object. For MST is for navigation. Important one is for navigation and motion perception, eye movement, navigation, right? And so that's MST of the dorsal one. For ventral one, so ventral there's V1, V2, V3, V4, and IT. V4 is important for object color and shape analysis and recognition, while IT is kind of like an output from V4. And with regards to IT, is important for memory and facial recognition. Yeah, for perception, visual perception, and memory. That's recognized faces.
주원아 중도야.
Collaboration around visual
That's
perception,
actually good.
identifying and assigning to objects.
뭔데? 와 시험인데 과외를 해? 근데 너 볼 거야? 에버랜드. 그럼 표 끊어. 표 끊고 뭐 늦게 합류하고 우리 아침 가니까 우리. 아직 그거 있어. 그래. 아니 나도 가고 수능이 오는데 아까 속상하잖아.
주원아, 내가 잘 챙겨줄게. 보고 하라고.
아니
내가 이 시간이 지나면 내가 진짜
미국이
이거
주생이 주는 모든 게 있어. 약간 센점 너무 그게
지하
고등학교 그 말인가
뭐라
친구가 얘기했어.
근데 나 20년 작도 이상은 내가 여기서 잘해줄게.
그래서 내가 부모님 편하게 알려주는 거 해주자. 그래서 그러면 예약한 거 알려주고 그리고 내 계산기 나오기 싫어했어. 내가 부모님한테 돈이 아시다고 다시 내가 물었어. 너 이렇게 봐. 아니 비싸냐 이렇게 알았어. 괜찮지 않았어? 거지. 그 어려운 조건을 아직 되겠어.
주원이를 모든 게 없어.
막 주원이 온다니까 막
이런 느낌.
방금도 그랬어.
자꾸 많긴 하네.
마음도 없대. 반박을 거의 없었어. 그냥 불만 있는 목소리로 아 맞아. 불만 있으면 반박을 하잖아. 반박을 안 해.
I guess it's orientation selective, is it
네가 주인공이야.
sensitive
아니잖아.
to wavelength and contrast of light, and there's on and off center with antagonistic surrounding. Center surround structure, right, for the receptive field itself, while at the striate level, striate cortex level, is direction selective, orientation selective. It's not as sensitive to wavelength, but it's more sensitive towards binocularity. Striate cortex, and in the extra striate cortical areas is more of the sensitive to recognition of objects, shape, color, motions.
아니 근데 방금 전화 받은 거 있잖아. 사실 공개 촬영이시 주변에 다 이호들이 다 있더라고.
아니 그러니까 이게 정치잖아. 논리가 안 되니까 살짝 지금 분위기랑 감정을 표현해야 돼.
뭐야?
그러니까 또 아니 이게 너무 필요가 없지 않냐 이러면서 말을 막상 내가 이 말을 주장하면 그 말에 대해서 뭘 안 하고 나중에 가가지고 꼬투리랑 잡아가지고 이렇게 그 짝씩 풀려잖아. 아니 그 짝 표시도 그렇게 안 하고 있는데 이러면 안 되지.
아니면 뭐하지?
그냥 정상만 주네. 어차피 정상은 내가 만들었어. 아니
정상은 내가 만들었어.
너가 만들었어?
그때 왜 정상하면서 밥 먹으면서 같이 그냥 넣자 이랬지. 아니 다 같이 있었어.
그런가?
그때 밥 먹을 때 육바에.
너가 만든 내가 만든 결국은 누가 만들었는데 우리가 초대하면 되지. 아니 그건 뭐 공식법. 그냥 그쪽이 친한 사람들끼리 신시적으로 만든 거겠지. 정상적으로 말 그대로 정상만 무슨 의미가 있어? 이거 어쩔 수 없이
정상 방이.
Move the oval window. And the movement of the oval window pushes the liquid. Movement of air, which then vibrates the tympanic membrane, and tympanic membrane movement moves the oval window, which pushes the fluid into the oval window due to hair shed deflection, neurotransmitter release in cochlea. And from the cochlea, the auditory vestibular nerve then brings into the brain and perception of the sound. Wow, amazing. Our body's amazing. Fuck. Sound waves. Remember that the frequency is basically the completion of one cycle of the sinusoidal wave per second, and that's hertz. Yeah, sound frequency number of seconds per second in hertz. Seconds of the sinusoidal wave per second, that's sound frequency. And then, so sound waves vibrates the tympanic membrane. Tympanic membrane leads to the movement of the ossicle. Leads to the movement of the ossicle, which directs the movement towards the oval window. Oval window movement pushes the fluid inside, which then inside the cochlea. Pushment of the fluid inside the cochlea or the cochlear fluid leads to deflection of the hair cells within the cochlea, which then leads to the depolarization and then leads to the signal transduction to the cochlear neurons, sensory neurons response. What was the name of that thing? Auditory vestibular nerve. Remember that the ossicles, there's the malleus, the incus, and the stapes, right? Okay, movement of fluid. It's more, I see. Power resistance and impedance matching machinery. tympanic membrane is a lot bigger than the oval window because it's easier to vibrate the tympanic membrane than pushing the fluid, and so you need to have a bigger tympanic membrane so that it has more vibration to basically be able to push the fluid in the oval window. So that's what we call impedance matching machinery. Match the difference in the resistance to push the fluid and the vibration of the membrane using air. That makes sense. The middle ear sound force amplification. So remember from this earlobe, which is what we call the what was the name of the earlobe? The pinna. The pinna, which directs it to the middle ear, the auditory canal, directs it to the auditory canal, and then sound wave vibrates the tympanic membrane. Pinna, auditory canal, to the tympanic membrane, vibration to the tympanic membrane, moves the ossicles. Ossicles are the malleus, stapes, and something like one more, incus, yeah. Malleus, incus, and stapes. And then movement of these bones leads to the pushing of the oval window and pushing of the fluid, the cochlear fluid. Pushment of the cochlear fluids leads to deflection of the hair cells in the cochlea, which leads to the membrane depolarization, which is then transferred to the vestibular auditory vestibular nerves, which then is processed in the brain. Middle ear sound force amplification by the ossicles. And then remember the difference in the in size of the tympanic membrane with the oval window. Remember, oval is quite small, but the membrane is quite big, and this is what we call an impedance matching machinery because it's much harder to basically push fluid compared to vibrate the tympanic membrane. And so you need to have a larger tympanic membrane so that you have a larger vibration in order to be able to push the fluid in the what was the name? Oval window. So that's the impedance matching machinery. Sound force amplification by the pressure force per surface area, greater pressure at the oval window than tympanic membrane moves fluid. Yeah. It's also amplified by the ossicles. The attenuation reflex response when offset of loud sound causes tensor tympani and stapes muscle contraction. Malleus, incus, and stapes. Tensor tympani and stapes muscle contraction function adapts ear to loud sound to understand speech better. Stapes muscle contraction. Where is the stapes? Stapes. There you go. So the contraction, I see what it means, yeah. Causes tensor tympani and stapes muscle contraction. Tensor tympani muscle. So connects tympanic membrane to inside of the inner ear. Oval window, vestibular. So the oval window itself is labyrinth. The labyrinth is for vestibular and auditory inner ear. Cochlear, perilymph fluid and scala vestibula and scala tympani. Where is the scala vestibula? Scala vestibula. Wait a minute. Fluid and scala vestibula. Where's scala vestibula? Perilymph and scala tympani and fluid and scala media.
나 일요일에 시험이야. 너네랑 같이 있으니까 시험 봐야 돼. 4시부터 해야지.
밤에 봐.
밤에 봐.
와, 시험이 가는데.
Local clear potential.
같아.
뽑히겠어?
Basically, no clear potential. No lymph. Electrical potential more positive than perilymph.
이거 잠깐 가만있어 본 거 아니고.
어차피 그 온라인 영상 안 보고.
Wow, amazing.
나 시험인데 뭐해?
나도 시험인지 몰랐어.
보통 일요일 몇 시간 하지?
심지어 10시부터 연습해.
이거 막 말을 멈춰버리지 않겠어? 앞으로 끄면 초밥방에 올려라. 아니 그리고
너무 올린다 진짜.
벌써 전제가 아니 이거 29년도에 들어온 사람 그런 거 아니야? 맞죠? 그게 딱 준영이 빼고
Physiology of the cochlea, motion of the wall in the precious period limit.
근데 그게 진짜
Physiology of the cochlea.
자신이 보고 있어. 나는 눈점을 해가지고
Motion of the bu분의 precious period limit into the scalp vestibuli. Okay. So pressure of the period makes round window membrane bulge. The response of basilar membrane to sound structural properties wider at apex. Stiffness decrease from base to apex.
짝짝한 상황에서 정치질 하려는 거야. 정치질 할 이유도 안 돼, 따지고 보면.
Dense basilar membrane. Dense basilar membrane. Your base moves towards apex.
말했을 때 너가 계속 맞지? 내가 미안.
So those are the paradigm steps.
그래서 내가 진짜
I see what he means.
이거
So then the stiffness decreases from base to apex, wider at apex.
뭘 미안? 와. 여자친구야? 아니 뭐 미안한데? 아니 여자친구도 그 상황에 미안 안 해.
미안하다.
Oh, because at the apex it's wider and also it's less stiff. It can basically be moved by lower frequency sound. I see what it means. Okay. Wide and floppy disk. Sloppy toppy. Tonotopic nap. Your cells have different sound, like bass.
이게 만들었으니까 써야지. 훨씬 나쁘지 않아. 아니 그 굳이 이렇게 만들 필요도 없어. 아니
Movement of fluid.
상상이 어떻고 원래 그냥 친해진 사람.
Dictorial membranes. Stereocilia. Extraterritorial membrane. Like left. It's not equal. It has different.
어때? 내가 직접 육성한 스카이프가 10년이 아니라 이게 능력치 20 초로서 어때? 내가 직접 육성한
몇 강인데?
몇 강 그런 거 없어요. 그러니까 실제랑 똑같은 거야.
Oh, so that's a hair cell. Inner hair cell, outer hair cell. Oh, like the. I see. The bending of the stereocilia. Wait, where's the stereocilia? Wait, there's the stereocilia.
너도 주시는데 이렇게 해가지고.
봤어 이거 5년 전에.
So when the basilar membrane is being floppy like this, it kind of moves the stereocilia, which then deflects the stereocilia. If it's deflected the stereocilia, it leads to membrane depolarization. Is that what it's saying? I think so. Sound basilar membrane. Sound basilar membrane upward, reticular lamina up, reticular lamina. Where's reticular lamina? The stereocilia bend outward, which then leads to the influx of the potassium ion because the remember that endolymph has membrane potential is 80 millivolt, which is really positive, which means there's a lot of potassium ion in there. The only extracellular fluid which is rich in potassium ion. So it's a mechanically gated channel, so that's why. Oh, interesting. So when it deflects into the direction of the short hair, It closes when it deflects the direction of the long hair. It opens, which then leads to the influx of the potassium ion, which then leads to depolarization. Which then also open up the voltage gated calcium channel, which then leads to the so that leads to the release of the neurotransmitter, because potassium ion is needed for the release of the neurotransmitter. Okay, for the binding of the venous snare to the C snare, right? Yeah. Okay. This is much easier than I thought it would be. And then the spiral ganglion neurite. Spiral ganglion neuron, which is here, which is a spiral ganglion neuron, which is part of the auditory nerve. Inner ear innervation of the hair cell. One spiral ganglion fiber synapses with one inner hair cell, numerous outer hair cells. Oh, I see. Amplification by outer hair cell, cochlear amplifier function, sound transduction. Motor protein change length of outer hair cells, Preston protein required for outer hair cell movement. Okay. Innervation of the hair cells. Auditory pathway. Oh, now I have to learn about the auditory pathway. And I didn't listen to the professor during this time, that's why. Ooh, am I fucked? Maybe. Amazing how little hair could do such grasping wave of sound. Wow. You actually listened to my lecture about the hair deflection. Amazing. Wow. Yeah. Our body is amazing, I know.
그래? 뭐 이거 현장에서 대학생 이전 학생 좀 줘.
Ipsilateral to ventral cochlear nucleus. Ipsilateral, and then from the ventral nucleus, we're okay. Both ipsi and contralateral. And then lateral lemniscus. And then the medial geniculate nucleus and an auditory cortex receive the sound. Thalamic nuclei for processing auditory information. Cursor frequency for the additional Texas monitoring. Irish noise, binaural. What does that mean? Binaural.
진지하게 관심 있는 거야.
Coding sound intensity, coding information about stimulus intensity and energy. Linear potential of activated hair cells is not
말이 안 통하잖아.
근데 자기가 그냥 열명 가기 싫고
그러니까
저사도 슬슬
말을 하면 되는데 그걸 그 말 안 하고 계속 모두가
Cochlear nucleus. Wait. You mean the ventral cochlear nucleus?
이걸 안 하잖아. A가 B야? 한데 B가 C야?
주머니 지상 많이 무사히 성이 연관이라고 지성이 신경이 연관이라고
There's also doors.
같이 가면 재밌지 않아요? 그게 더 재밌을 것 같은데 역시.
These to act like apex basically member resonance by increasing low frequencies is preserved in the auditory nerve and cochlear nucleus.
성현이한테 가자
제일 important.
Auditory nerve and the cochlear nucleus.
입이나 같이 가서
Bands of cells with similar characteristic frequency increase from anterior to posterior.
이거
I see.
공부도 열심히 동아리도 게임 줄 알고 한번 쓰는 원래 제가 근데 이제 그건 원래 제가 관심할 거 있잖아.
Face locking every cycle or some cycles.
정이랑 되게 오래치만
Sound localization, localization of sound, horizontal plane.
내가 이제 공리적으로 생각하면 한명 ISD가 친구 있어가지고 초반에 좀
이거 만났으면 제이랑 더 빨리 지금
이제 반에서 많이 나오죠.
I look like a crazy man. So intraoral time delay difference in time for sound. Intraoral delay.
자기만이 하지 않는 내일 겸 게임할 때 근데 이제 이거 하는 거
근데 이거 괜찮지? 저러니까
나 갑자기 왜 내가 혼자 있는 게 더 좋아하는지 얘가
얘가
진짜
진짜
이렇게 해보고 이런 거
그래 멋있는 거 있으면 난 지금 이런 그럴 수 있는 건데 나도 원래 같은 이렇게 가게
아니 나 그냥 혼자 있고 싶어졌어
이런 스트레스
갑자기 스피커폰 들고 미드라고 해서 나랑 통화를 못 들어버리고
그 신기하다 보여 이게 자기가 약간
그러니까 그랬는데 전화하기 전에
Sorry, I didn't finish it.
우리 존나 빠졌어 내가 빠졌을 것 같아 왜 말도 안 하고 10명이나 좋아하는데
나도 눈치주고 그렇지 않냐? 이래서
And very soon, the sound was just right.
그러니까 행정학과 지구한테 비슷하지 라고 말하면 안 되지.
How did they reach it at the same time? The fuck? Why? How did they reach it at the same time? Sound, plane, vertical sound elevation.
다룰 수 있어? 너 재미나 이거 너무 아프다.
아니 지금 갑자기
너 이거 바람이
장애인 좀 맞았는데
이거 AI 바람이야. AI 바람 혹시 몰라?
그게 뭐야? 재미나게 바꾸는 거?
나처럼 아무도 해야지 GPT.
아니 나 GPT가 왜 안 쓰냐면 그때 어떤 강의 영상을
Oh, I see.
녹화한 다음에 5분 단위로 잘랐어 내가 재미나게 박았거든. 근데 GPT는 안 박혀. 그러니까 이게 더 작게 잘라야 돼. 근데 제미나이는 5분 받는단 말이야.
똑똑하네.
그래서 진지하게 1시간 반 강의 녹화한 다음에 그거 5분 단위로 잘라서 박았어. 근데 그러니까 이거 고장 났잖아. 진짜 이제 여기서 쳐도 안 나온다.
Similar characteristic frequency.
그래서 내가 들어봤잖아. 그러면 이거 다시 박으려면 5분 단위로 자르고 박아야 되고 박으면 이거 로딩이 걸려. 로딩까지 아무것도 못해. 그래서 나는 그거 한 진짜 한
그래서 이거 몇 학점에 나왔죠?
지금 15학점 21학점 신청했다가 2개 들어갔다 15학점.
한 개만 들어가지고 아니 한 개만 18학점만 신청하고
그러니까 이제 애초에 21학점을
힘들게 시간이죠.
들을 생각 없었어.
아 하다 보면 그냥
나 제가 축 같은 거 하나 하려다가 하나 축 같은데 다른 하나도 많이 해가지고.
나도 이탈 시간
I'm gonna take a break.
하는데
I'm going to take a break and I'm just
SAT
gonna
근데 쉬운데.
I'm gonna take a break and I'll see you guys later.
그러니까 꼬았던
Bye bye.